Well, folks, I recorded this podcast many years ago and it's been on the channel also for a while. But finally, somebody said there is too much noise, and I see that indeed there is too much noise. Honestly, there is an impact of global warming on my recording because when I lived in Mumbai, which was still, about 6 months ago, I lived without turning on the AC in my apartment, so I used to have the windows open and there was always some breeze, which is nice, but that got into many of the recordings. I checked and somehow either missed the noise because it was not continuous, or I decided it wasn't too bad. But anyway, this podcast I'm redoing after so many years is on the trends in global tropical cyclone activity. You may already be following this topic or it may be new to you. So let me just summarize it this way. The answer is not very clear as to exactly what the global tropical cyclone activity is doing under global warming, or even regional ones are, because there are so many ways to look at it. There are things like accumulated cyclone energy, categories of cyclones, number of named hurricanes and cyclones, cyclones that last only for less than 2 days or longer than that, and those that rapidly intensify, those that rapidly weaken, and so on. But I think Gabe Vecchi and Adam Sobel have a paper that came after this one that basically says we don't know exactly how cyclone frequency will respond to global warming. So you can categorize it into many things and look at the trends, which is what this paper is all about. It's kind of a review. It's a nice review. I'm going to be brief, unfortunately, and you have to read the paper, which is, DOI is given here. And it's a very nice paper. If this topic is of interest to you, then you should definitely follow up. So altogether, we start with named storms, so that at least gives you an idea that they got transitioned into actual storms and were not just depressions. So you're looking at global. So here, when you have these kind of a shading that is a statistically insignificant trend. So you're looking at global, no statistically significant trend. North Atlantic hurricanes obviously has a trend, and Western North Pacific actually has a negative trend, and then you jump to Northern Hemisphere and you can see that it's the entire global picture is dominated by the Northern Hemisphere. We'll see a map in a minute. You can look at named storms lasting for less than 2 days. Then you see a trend in the global numbers, and that says something that maybe more named storms are being born. They're not lasting very long. Maybe ocean warming, especially upper ocean, allows the seeds to grow, but they don't sustain. Within 2 days, they die. So more of the number of seeds are getting turned into seedlings of tropical storms, but they are dying away. And same for North Atlantic, Eastern North Pacific. The Eastern North Pacific, not the Western. Western North Pacific is where more than 30% of the global cyclones are born as typhoons, but Eastern North Pacific is somehow here getting a trend. Western North Pacific is insignificant, and Northern Hemisphere again dominates. If you look at named storms lasting longer than 2 days, then North Atlantic still holds up, but the numbers drop from about 3 point something to about 1 point something. And if you look at just hurricanes, then global versus Western North Pacific numbers are negative, but overall we'll see that the trend is not significant for the global numbers. So what does this mean? So dynamically, physically, we want to understand this, especially when you see that accumulated cyclone energy is also decreasing, which is related to cyclone genesis parameters like vertical shear, which inhibits cyclone activity or growth of a cyclone from a seedling and so on. So major hurricanes, nothing exciting there in terms of significance, and similarly category 4 to 5 hurricane percentages Some trends, but statistically not significant. Category 4 to 5 hurricanes. Global, again, remember global, North Atlantic, Eastern North Pacific, Western North Pacific, North Indian Ocean, Southern Indian Ocean, South Pacific, Northern Hemisphere, and Southern Hemisphere. That's what we are looking at. And accumulated cyclone energy, you can look up the definition elsewhere on my podcast. You can see it's actually decreasing globally, and Western North Pacific is dominating that, and Southern Hemisphere is dominating that as well, and South Indian Ocean. So there are interesting mix of results. So this is the caption in the end. I'm going, there are many panels. Oops, I can put the caption in the beginning or at the end just to give you words before I show you the caption. I put it at the end. So here, 50 knot rapid intensification change events, strong trend in the global, but not so much for global weakening ones. And Western North Pacific also has a fairly strong, but Northern Hemisphere dominates, and even South Indian Ocean, North Indian Ocean, and Southern Hemisphere show up in this as statistically significant trends. So per decade linear trends, I think the study looked at 1990 to 2021, so 3 decades. Per decade linear trends for named storms lasting less than 2 days, named storms lasting greater than 2 days, hurricanes, major hurricanes, category 4-5 hurricanes, category 4-5 hurricane percentage, accumulated cyclone energy. So basically what I already said. It's important to categorize this way because you're desperately trying to understand what is a robust signal in the tropical cyclone activity to global warming, and just to be sure that we are not adding too much noise, we are only looking at named storms, and we have picked a period where the data is very solid, right? You can get cyclone data going all the way back to even 100 years, and many people use them in various studies, but trends need to be much more robust. But then when you do 30 years, you always can argue whether it's into decadal variability, which could be possible for accumulated cyclone energy. So we need dynamic consistency to what we are saying. So here again, looking at, globally, you can see adding all of them together for this study period, which is 1990 to 2021, hardly any trend, statistically significant trend in the named storms, but named storms lasting less than or equal to 2 days has definitely increased. We already said that. Named storms lasting longer than 2 days have decreased in the meantime. What does this mean? So you can read the paper to see what the conjectures are. Hurricanes decreasing here, and let's see. Hurricanes, major hurricanes here, almost flat, and category 4 to 5 hurricanes, a slight increase, and D is global percentage of hurricanes reaching category 4 to 5. So this storyline has been told many times in the media. When media asks every time there is a hurricane and does something exciting, whether it's hitting Puerto Rico or Caribbean or US or even Europe, some have turned around and gone back to Europe, then media wants to know what's the role of climate change in it, what global warming is doing to cyclones, and scientists have to be careful, but they have to give some exciting lines. So they always say total number may not be increasing, but more storms are getting rapidly intensified and reaching stronger categories. Okay, so it's a robust statement, but the details of the scientific difficulties are that we don't know exactly how the frequency of cyclones. So you are thinking here now duration, intensity, and frequency, just like heat waves or extreme rainfall, and we do the same thing for cyclones. And in heat waves, we say duration, intensity, frequency, and scale of the heat waves are increasing, but cyclones, as you can see, are a mess. So accumulated cyclone energy dropping, and there are regional differences, but we already saw that. So what does this mean? Again, it is related to overall storm activity during the season. So you can see that parameters like vertical shear, which are increasing, and also the upper tropospheric temperature, which reduces the efficiency of the Carnot cycle, which is what the cyclones are in terms of going from warm sea surface temperatures to cold upper atmospheric temperatures, which is Kerry Emanuel's idea, a nice idea. But you can see that rapid intensity change events are increasing, but the scatter is extremely large, but rapid weakening extremely large, well, it's large, statistically significant trend. Rapidly weakening cyclones are also increasing a little bit, which is consistent maybe with the idea of cyclones less than 2 days increasing, but cyclones longer than 2 days decreasing. So there is some weakening happening as well. Damage, of course, this can be misleading because more and more people may be moving into the paths of hurricanes, which is the argument by people like Roger Pielke Jr. So we have to just take it for what it is, okay? But amount of rain is increasing with ocean warming, especially in the coasts. Cyclones are moving slower, and they can park at the coast because they are getting enough energy from the coastal waters on the ocean. As they go on land, they fall apart, but they are bringing a lot of moisture, dumping a lot more rain. So you are increasing damages overall, even inland. So overall, we are looking here at shear. So you can see there are places where shear have increased. This is the strong Western North Pacific typhoon region, some trend in the Indian Ocean, but more in the south, which shows up in some of the quantities, decreasing over here in the Atlantic, but too close to the equator, which matters for rotation. But you can imagine that this is to the south here, but you can imagine this is where a lot of the seeds get thrown, and if they grow into tropical depression, into storms and then cyclones, they go off into they go off into subtropics eventually. This is the relative humidity, so you can see that there is some reduction in relative humidity, but increase in relative humidity. So there is an overlap of increased shear and increased relative humidity over the typhoon region. Definitely this region is seeing trends, but trends unfortunately doesn't mean every year is having more cyclones. So when few years are quiet, like it's happened over the Arabian Sea and the Bay of Bengal, people begin to say, where is this trend you talked about? So out of 10 years, you may have 6 years with more number of cyclones. 4 years may be quieter, in fact, than normal. So we have to convince people that we are not joking. This is a serious matter. This is a PI. Good Lord, what index was this? Let's see. I sometimes blank out on these things. There is the El Nino index. I should clarify that, should I? Okay, that's homework. Why don't you check out? This is some index pressure. I suddenly blank out. Sea surface temperatures are warming, but that's not enough. I'm involved in some work showing that, in fact, you can have warmer sea surface temperatures, but thermocline can be moved in a way that you have colder waters below. So the cyclone chews into the ocean and doesn't grow, because you have colder waters below. So it's not just the sea surface temperature. There is the hurricane potential, which is the warm water above 26 degrees C and so on. Genesis indices are now including ocean parameters as well. This is the tropospheric temperature at 200 hectopascal. If that warms, then obviously the Carnot cycle efficiency drops. This is the El Nino long-term index, as it's called, basically about the east-west temperature gradient and how that affects the overall cyclone activity, because that does matter in terms of the energy available, the shear, the overall ocean heat uptake, and where that heat goes, etc. Okay, I'm being a little brief, but please read up the paper. It's a nice paper, it's an important topic, but I'm being brief nonetheless. In fact, briefer than when I did it last time, because I'm hungry. Just kidding. But essentially, this is a very important topic, and yet, as you can see, there are a lot of unanswered questions. One of the biggest concerns in my mind is that we are doing all these things without having data or the models that are actually resolving hurricanes. There are hurricane permitting models now which are running globally at 25 kilometers, and we use them to say a lot more things about hurricanes. GFDL has produced a series of papers on those. But the global warming models typically have lower resolution, so you're using some indices to say something about what cyclones will do in the future. And the past we are trying to interpret with various reanalysis data which also don't have the resolution, and the data definitely doesn't have vertical resolution needed to resolve some of the hurricane cyclone processes either in the atmosphere or in the ocean. So we are somewhat in the dark, but many of the results are still statistically significant and robust, like the rapid intensification, number of cyclones lasting less than 2 days, accumulated cyclone energy dropping, and so on. So understanding is different, and then you have to put processes behind them, and then you have to understand what that means for the future. So we have some work to do. Okay, so I will replace the old one with this. If you have heard the old one, you can listen to this and let me know if you're happy with the sound. Okay, thank you.